All right, good morning, everybody. Thanks for coming. I know it's early-ish. It was for me anyway when I was in school, so I appreciate everyone coming out to hear my talk. Hopefully it's worthwhile to you. Really, I titled this, how information technology is used in manufacturing today and why. As I mentioned, I work for FANUC. FANUC, we make robots, is what we do. I've been there for 16 years now. I started as an engineer, so I began making robots and programming robots, and I've eventually got into sales and marketing and things like that. And I've really dived pretty deep into information technology and business analytics and the Internet of Things and stuff like that. So in terms of today, really what I wanted to try to do is give everybody an overview of who we are so you have an understanding of who FANUC is. I wanted to talk to you about how we use analytics, because Michigan State was a big part of FANUC starting to use business analytics. I want to talk about the Internet of Things a little bit, because I know it's a really cool buzzword that's out there right now, and we're actually paying attention to that, and I think we've got a fairly innovative way that we're using it. And then I want to get into why. Why the heck does this matter to everybody? Why are we doing this, and why do we think it's important to be able to be able to use this? And then Dr. Rodimer told me that I've got to get a quiz at the end, because there's always a couple questions that show up later for your exam. So pay attention to that. We'll go through a couple questions at the end. So who's FANUC? This is a little bit techie, so if you don't quite grasp some of this, don't worry too much. But FANUC, we're a Japanese company. We started by making motors. I'm not sure if this pointer works very well, but you can see up there, it's called a servo motor. And really, you know what a motor is, but the difference between a servo motor and a regular motor is a servo motor can turn, and you know exactly where it is at all times, very, very precisely. So as the motor's spinning around, you know really, really precisely where it is. And we use that motor to make machines that manufacture things, and we also started making robots. So in the early 80s, we started making robots to put cars together. And since then, robots have exploded into all sorts of different things, and I'm going to get into some of that in a little bit. But overall, we have, and you look at some of the numbers, we have 15 million motors installed worldwide. Really focus on the robots. We have 360,000 robots, just FANUC, installed worldwide to date. To give you an example, if some of you may or may not know how robots are used or what they're used for, but there's a tremendous amount of automation out in industry today. This is where our headquarters is. Actually, I was there yesterday in Tokyo, so if I fall asleep in the middle of this lecture, you'll know why. I just flew in yesterday from Tokyo, where our office is at the base of Mount Fuji. In Japan, it's called the Yamanashi Prefecture. So you see all these yellow buildings. There's going to be a big yellow theme here. Our robots are yellow. You can see in Japan, they paint the buildings yellow. In Japan, the cars at the factory are yellow. The robots are yellow. I have a yellow coat that I have to wear when I'm there. We have yellow hard hats when we're there. So everything's yellow. I didn't wear any yellow today, but I have a lot of it. You can see all the things we make there. We can make 3 million servo motors per year. We can make 360,000 CNC machines. That stands for computer numeric controlled machines. We can make 60,000 robots per year. 60,000 of another machine called a robo-drill, and 3,000 laser machines, laser processing machines per year. We actually use 2,700 robots in our own factories themselves. So we actually have a lot of robots that we use in our own factories. Here in America, my office is down in Rochester Hills. So just down 75, if you're on the east side, just down 75, right by where Chrysler's headquarters is. Just behind there is where our headquarters is. So we're a wholly owned subsidiary of our parent company in Japan, and then we also have a secondary headquarters in Chicago where we do the CNC products as well. So that's where FANUC is. We also have offices all across the United States. I wasn't going to get into it, but I worked at our Southern California office for a number of years before I came here. We have offices in Charlotte and Toronto and a bunch of other places as well. So we're a wholly owned subsidiary of FANUC Japan. We are the world leader in robotic automation. We're the #1 company in the world by far in terms of robotic automation. Up here you can see some of these pictures. These are all pictures of our factories. So part of what I want to talk about today, I need you to have at least a semi-understanding of what robots are used for. And you can see up here some of the pictures. So these are robots making other robots, robots making some machines, robots making motors, robots assembling other robots. So when you think about robots, you really need to think about where they're used and what they're used for. If you watch any sort of television or movies, you may think of us from stuff like this. So our robots were in the movie Terminator, they were in Iron Man, they've been in commercials. So anytime you see something yellow, it's ours. And then sometimes the movie companies paint the robots. So like the one in Iron Man, they painted green. The ones in this one, the ones in Terminator, we gave this company brand new robots. But when they got there, they looked really shiny and new, and it didn't fit in for the movie very well. So they actually painted them. They had like the costume guys paint the robots to make them look really old. And when we got them back, we left them that way and sold them as is to people and told them that they owned the robot that was in the Terminator and stuff like that. So that was like a special deal that we ran. So we've been in Spider-Man, Terminator, Transformers. So that's kind of a cool part of our business as well, that people like to put robots in different things. So, but in manufacturing, a lot of people say, where are robots used? Or what is automation all about? And I like to think about the show called How It's Made on I think it's on the Discovery Channel or the Learning Channel or something like that. Do you guys ever see that show, How It's Made? I love that show because when I look around, everything I look at, I think about how it's made. The chairs in this room, this podium, this computer monitor, that projector, the garbage can, the skateboard that someone brought in here earlier. Like, how is it made? And so when you think about that, that's where automation comes into play. You can think about all the different markets that we have. You know, flip-flops, pharmaceutical stuff, computers, couches, jewelry, cosmetics, farming, aerospace, construction, automotive, beverages, food, wood, everywhere. Anything that gets manufactured, there's some level of automation today because we need to make things more productively than we made them before because we don't want to spend, you know, $600,000 for a car these days. We want to spend what we're going to spend. So the market's driven us to provide things at a more competitive price, and in order to do that, we need to be more efficient at what we do. So when you think about automation, really just you got to think about manufacturing in general, and it's everywhere. And we're everywhere, which is kind of a cool part of my job. So how did we start using business analytics? That's any questions real quick? This is kind of informal. I don't know how people normally teach classes here, but if you have any questions, go ahead.
Yeah, do you guys only produce robots for like industry, or have you guys looked into selling robots to individuals?
Oh yeah, no, hey, you want to buy a robot, I could sell you a robot right now. But so the question was, do we just sell robots for industry, or do we sell robots for individuals? And it's a good question. We haven't gotten into personal robots. So like if you wanted a robot to fold your clothes in the laundromat, we don't do that. But that being said, I sold a robot to a guy that he came in his car and picked it up. Now he ran a small job shop, so his business was him and his wife, and they made little pieces of parts for the aerospace industry. They only made a handful of them a day, but he wanted to not work anymore, so he bought a robot, so the robot would load his machine instead of him and his wife doing it. So we sell robots to very small people and very large people as well. But in terms of personal robots, there are a lot of people getting into personal robots these days. But no, we don't. We just sell them really. They're more industrial. We do sell them into education, though. That's actually a good thing, because we're teaching. Most of you guys are business students, but for people that are more into engineering or going to a 2-year tech college or even at the high school level, we have a whole business unit dedicated to selling robots into industry to teach people how to use robotics at an early age, even down into the grade school level, which is cool. Any other questions? Yeah?
Who are your biggest customers within the automotive industry?
Well, the big three, GM's our largest customer. So really everybody we deal with everybody in the automotive industry. The automotive industry is currently our largest market. It's where people have automated the most. But the emerging markets, the other markets that are around, are getting big fast. So food and beverage, pharmaceutical, aerospace are all getting big really fast. But we sell, for FANUC in particular, GM, Ford, and Chrysler, Volkswagen, Mercedes, Hyundai, Everywhere that there's an automotive plant in the U.S., we pretty much have robots there. Okay? So, as I mentioned, we've been selling robots since the 80s, since the early 80s. But it wasn't until a few years ago, I taught this class 2 years ago, and we started working with Michigan State's MBA program, and I ended up hiring a guy. His name's Robert McElmurray from the MBA program here. And he brought in a wealth of knowledge. He wasn't an engineer, but he talked a lot about analytics and how they're used and why they're used. And so we started really digging into this of how we're going to use business analytics and why. So working with State, we started FANUC Market Analytics. And really what we're trying to do is try to predict the future. Robert always talks about the Moneyball guy and trying to use analytics like that. And so say you're GM. You already know that you need robots. I mean, that's a well-known thing that you need to know. What we're trying to use analytics for is trying to predict what's next. So rewind a little bit. Think about what happened like in the 50s and 60s, where we used to make furniture in the U.S. like crazy. We were a huge producer of furniture. It was mostly in the Carolinas. And something happened in that industry. China happened. And people in China were able to make furniture faster and cheaper than they were here. And it was at a quality where we accepted it, that the market in the U.S. accepted it. And guess what? We don't make furniture in the U.S. anymore. It just doesn't happen. It's all made overseas. So that industry got lost. That manufacturing industry was lost to the U.S. and went somewhere else. And we don't want that to happen, because and I get to it in a little bit, but the manufacturing industry in the U.S. is really important for a lot of different reasons. So what we're using analytics for is we want to know what industries are going to need to automate next. And we try to know before they know. So think about like this skateboard over here. Say that's made in the U.S. I don't know if it is or isn't, but say that it is. And there's a company that's making these skateboards. And as time goes on, that company is not really thinking about automation, or not really. They're just trying to think about selling skateboards. And that next step, so one day they realize that they're not that competitive anymore, so they're not selling as many skateboards as they were before. And all of a sudden they realize, well, if I go and make it in India, then I'm going to get a better price for it. Or I'm going to be able to get a lower cost for it, and then I'm going to be able to keep selling them in America. And so all of a sudden, that's kind of how business shifts to other areas where they hear or think about doing something different. What we're trying to do is predict that from happening before it happens. So I could go to skateboard manufacturer and say, I can sense that your industry is at a point where I think I can help you automate. I think I can help you keep your manufacturing here, create a lower cost, make you more competitive, raise your productivity, allow you to make more skateboards and be competitive. And if I can hit that guy before he goes off and starts exploring taking his production somewhere else, then I've saved the industry and I've kept it here. And that's how we're using analytics. Dr. Rodimer and us, we came up with a very simple flow chart. And I'm not going to go through the whole thing, but in essence, we were trying to pick certain industries and do an assessment. And working with Robert, what we did is we found a couple different metrics that we were going to use. So we felt like, and these are all public metrics, we felt like if we could see what the capital expenditures for that certain industry were from the annual survey of business manufacturers, we could look at what the revenue was for that industry, we could look at how much labor that industry put into each unit, which is also from the Bureau of Labor Statistics, we could look at how many employees they had, we could look at how much output per hour they did, which is how productive they are now. And then the last factor was a capacity utilization number, which is something that comes from the Federal Reserve, which says this factory should be able to produce 100 whatevers per day, and they're currently producing 50. So they're only half utilized. And we felt that if we could take these data points and look at them over time and try to analyze what that looked like, we could try to predict whether an industry was going to stay here. Really what we were trying to do is say whether an industry was going to go offshore and there's nothing we can do about it. Or whether the industry was going to stay here and it didn't matter whether they automated or not. It was going to be here, it was going to stay here no matter what. Or what we were really looking for is the tipping point companies. Were the ones that they could go offshore, or if we helped them automate, they could stay onshore. Or if they were already offshore, we could help them automate and come back onshore as well. So this took a lot of work, and every one of these charts is different. So this particular one's for the medical device manufacturing market. And you can see here, if we normalized everything in 2002 at 100, the CapEx is the dark purple one, which showed what there is. The capacity utilization is the dotted line. The value-added revenue is this one. The output per hour is this one. And the employment is this one. And what we found is that this particular industry had already begun to automate. So you can see here, their capital expenditures have gone up in the last couple of years. You can see that their output per hour has gone up, which is a result of automating. And their employment is on a slightly downward trend. And this happens most of the time, that output per hour is always on a higher curve than the reduction of employment. So people in manufacturing today, when I talk about automation, when I started talking about this probably 10, 12 years ago, it was a lot of, there's no way I'm going to automate because I don't want to lay off my people. I'm not going to walk in and lay off half my company and automate. I'd rather do whatever than do that. And then people found that they either went out of business or they lost to Chinese manufacturers, Indian manufacturers, whatever. And what we're experiencing now is a little more different, where people have been educated a little bit better to realize that what we automate are the dull, dirty, or dangerous jobs that are out there. That it was hard to find a person, or I guess it was easier back then. It's harder now to find a person that all day long was just going to sit here with a screwdriver and screw in this screw all day long. That's it, all day long. Their one job was to screw that one screw in all day. That was it. And that's why things move offshore. And that's what happened. People did that all day long. They just had to screw in one screw, and that's their only job. And that's terrible for people to do, I think. So what we've been doing is we train people to be robotic technicians, to be robotic service technicians, to be troubleshooters, to be programmers, all levels of education. You could have a high school diploma and become a robot technician. You could have a master's degree and become a robotic programmer. So we're reshaping manufacturing a little bit to where overall employment in manufacturing is going to go down a bit. It is. That's kind of the inherentness of the industry. But it's changing. It's becoming more high-tech. And I'll get into that in a little bit as well. So we analyzed this, and we found that medical device manufacturing is automating, and it is staying here, and it's probably going to stay here. And there are a lot of other factors that we looked into as well in terms of market regulations and things like that, where the industry itself said that people shouldn't make medical devices elsewhere because of the quality control that needs to happen when it comes to those things as well. And then from that, once we find an industry that we think has value or has that, we take the analytics one step further. So we said, okay, medical device is good, medical device is strong, we want to sell robots to medical device. Then we switched analytics to where we started utilizing, heat maps and things like that, where this is a map of the U.S. that says, where is medical device manufacturing? So now I can use this with my own sales force to try to identify new opportunities, new customers, and things like that. And so that's in a nutshell how we're using business analytics today. We're trying to find what industries are going to want to automate before they even know that they need to automate. And then once we understand that an industry is a prime target for us, we're utilizing it to create sales. And that's most of what people, if in essence I could say what people want to use business analytics for is to make more money and sell more things. And that's what we do. It's our ultimate goal is to sell more robots. And so that's how we use it. The Internet of Things. So that's another kind of buzzword these days. What is the Internet of Things? How are we using the Internet of Things? Let me see time here. We're using it to try to reshape the way automation is used in manufacturing today. That's what we're trying to do with the Internet of Things. Today, currently, when you buy a robot from me, so say you bought a robot from me, you buy it, you install it, it starts making something. It starts making podiums. The next time I hear about that robot is when it breaks. And you call me and say, I'm losing $1 million a day because your broken robot took down my production and it's terrible and I'm mad and I'm upset about it. So that's today the way things are. The robot is out there, it's doing its things, and we have no visibility of that robot at all. Whereas the way we want to shape things is that with the Internet of Things, when I sell you that robot and it starts making podiums, I'm always seeing what that robot is doing. I'm connected. It's all about being connected. So the plant's connected to it. I'm connected to it as the manufacturer. Anyone that has authorization to be connected to it can be connected to it. And we can start looking at it from various ways, shapes, or forms. So we're calling this a zero downtime initiative. So because in manufacturing, downtime's bad and people don't want it anymore. And this is a little bit of a lengthy slide, so I'm going to try to paraphrase it. But obviously, downtime is bad, especially when manufacturing is good. So today, automotive is fantastic. People are making cars like crazy. But if I have a robot that brings an automotive plant down, they literally lose $1 million an hour, and I don't want to be responsible for that. So people are willing to spend a tremendous amount of money, and we're spending a tremendous amount of resources to try and prevent that from happening. So what we were trying to do is we want to proactively detect and inform about a potential robot problem before it happens. We want to provide smart maintenance. So right now you have to maintain a robot just like you maintain your car. And currently we just say when a robot hits 10,000 hours of working, you should change the oil. But that's not really, just like your cars are being a little bit smarter these days, that's not exactly true. If you use a robot really hard, you might have to change it and maintenance it every 5,000 hours. Or if it's not working real hard, maybe it's 20,000 hours. So we're trying to add that in it as well. And then we're providing advanced analytics and reporting to the customers to help optimize their equipment. So today what we can do is I can go into a plant and the robots are all working, they're consuming energy, they're doing things. I can actually analyze how those robots are moving, and I can optimize their behavior to try to maximize or minimize your energy usage. I can maximize your productivity and your output by minimizing how much energy you use. We've done studies that says that a person going to work, how much energy a person consumes actually working. So driving back and forth to work every day, the lights, the heat, the food that's consumed, everything that's needed for a person to be at work. And it's about twice that of what a robot needs to run every day. So we've kind of done those studies as well. So in theory, what we're trying to do, I'll just skip over this slide. What we're trying to do is you have your plant running, and the robots are up on this. This is the Internet of Things. The robots are connected on Ethernet, and they're telling us all the time, hey, this is what's going on. This is how I am. This is how I feel. This is how I feel. So maybe something happens where the robot detects something that's wrong. And when it does that, it sends a message over a secure server to us that says something bad's happening. Our system instantly takes that part, automatically ships it. It gets to the plant with a notification that says, change this part out on the robot before it goes down because you don't want to lose any downtime. And it all happens automatically because it's connected. And at any time, someone can go in and look at a report and say, how are things going? And I'm always connected. We also collect torque data. So when the robot's moving around, there's a lot of technical stuff that's happening within the robot. But in essence, we're trying to see how the robot feels. And if the robot's feeling good or it's feeling bad. And if it's feeling bad, we can sense that and say, this is what the torque should look like, and this is what it actually looks like. And so, same kind of thing. Go through and change a new motor. We're also putting a lot of things on smartphones as well. So we have an app. FANUC has an app that you can have. It can be connected. You can get your whole plant up and running on this app. So if you don't want FANUC to be analyzing your data, you can analyze your own data. So as a business owner, you can go through, you can have supervisors with one version of the app, you can have plant guys with another version of the app, and they can always be kind of looking at what's going on at the plant level. The Internet of Things to us is about being constantly connected to the products that we sell and having the users of those products also be constantly connected to them. So these products are used first shift, second shift, third shift. They're used 24/7, 365. And from a management standpoint at a plant level, you can only touch it certain periods of time. But if it's connected all the time, you might get a text at 2 o'clock in the morning saying the robot's down or the robot's going down and please go in and fix it. So to us, that's what the Internet of Things is. It's being able to have the robots be always connected. The challenge has always been companies don't want this link right here. They don't want an outside company, this is us, talking or having a data link to inside their company. So we worked with Cisco to create some secure servers that is beyond my knowledge base, but it makes IT people feel very comfortable where we say, we worked with Cisco, here's this thing that if you put that server in between these two things, then everything's secure, and I can't go steal your company's secrets, but you can, you can send me the robot data securely without any risk of failure. Yeah.
In this flow, do you contact the customer before the good gets there? It seems like how you explained it that the repair part arrives, and at that point they know what it's doing.
No, we actually there is a contact before that. Right in here is kind of where we currently contact it. We currently have this beta testing at a few different automotive companies right now, and it's working really well. Where this happens just like that. Our robots are really reliable, so it doesn't happen often. But an automotive plant might have 1,000 robots in it, and sometimes they crash, and sometimes an operator has a mistake. There's a customer contact in here as well. And actually what we've done is we've gone to providing weekly reports or daily reports or monthly reports, whatever the customer wants, to make them understand kind of the overall health of the whole system. So that's what we're currently doing with the Internet of Things. Any questions there?
Do you ever have customers who are reluctant to buy robots from you because they don't want to give away trade secrets?
No.
The way you design robots, or is it not really a relevant factor?
That's not really. I'll talk about it in a second, where people are starting to use robots so that they can make things here, so that they don't have to go give their trade secrets to some foreign country that they don't have control over. But our robots, it's a tool. When you think about a robot, all it is it's a tool to help you do something automatically. For our robots, there's not a whole lot of trade secrets there. Sometimes we do get into where if the way someone's using our robots, so sometimes, like in the electronics industry, if somebody's using our robot in a way that the process is proprietary, then we're under a confidentiality agreement where we can't tell other people how that company is using our robot to do something that's probably the best way to do it or something like that. So there are ways that legally we do things with our robots that we can't tell other people what we do with our robots because we're under a confidentiality agreement. But it hasn't really prevented a sale. It just requires more paperwork. So the big question then is, why are we doing all this? And so for the next probably 10 minutes or so, I'm going to go through what we like to think of as Save Your Factory. So I've been kind of building up to this of, we're an automation company. FANUC's a global company, but I'm focused on North and South America. And this is particularly about North America. And some of the things about manufacturing, this is just some good data and some things that are happening within U.S. manufacturing today. So I've been giving this talk for about 10 years. And it reshapes itself every year. So as I mentioned, when I first started giving this talk, this was to inform people that they shouldn't necessarily move their production to China as a way to save cost, that you could keep it here and do things differently. Now people are starting to realize that. We've already gone through the shift of a lot of stuff going to China, and now we're starting to talk to people about things coming back from China or India, or people that haven't yet made that decision yet. So this has really changed over time about what this talk is actually about. The big thing is that we certainly consume a lot of stuff, but we still make a lot of stuff too. So this is imports and exports. This line is in billions of dollars, and this is a quarterly thing of 240 billion. So you can see the top is our imports and the bottom's our exports. And we have a trade imbalance of about $41 billion, $42 billion. So we import $42 billion more stuff than we export, which leads to reluctance on reliance on other countries to be able to provide us with the things that we need, which isn't necessarily a good thing. So why is it good to have manufacturing. For those of you, I've lived in Michigan for 10 years now, and I didn't have the greatest view of manufacturing until I started working for a robot company. But these are just some tips. If you're not too familiar with the manufacturing industry and why it's important, it's really, really important for the health of our country. It leads to GDP and growth and productivity. 70% of all the private sector R&D is in manufacturing. 90% of the patents that are issued are related to manufacturing. We are adding jobs. We've added almost 500,000 jobs since 2010 in manufacturing. Now, this is post-recession, so that's a little bit of a, we lost a tremendous amount of jobs in the recession, but they're coming back. Now, we've added 500,000 more since then. People in manufacturing earn more than non-manufacturing jobs, and it's certainly the backbone of the defense and technology industry. As I mentioned, we still are exporting a tremendous amount of goods. For the fifth consecutive year, we've been on a record-setting growth pace in terms of how much we've exported. And when you look at why manufacturing is important, 88% of the things that we export come from the manufacturing sector. So we're exporting a lot. We don't have that many raw materials, I guess, is the thing that is. We're exporting things that are created here. And this relates it back to GDP. All of our manufacturing, $2.1 trillion, is 12.4% of GDP. That's the largest subset of GDP out of all the things that kind of go into GDP. Manufacturing is in there. So, and we're second only to China. We're kind of back and forth. Last year, for a little bit, for a number of quarters, we actually exported more than China, and now China's back on top with exporting more than us now. So the paradigm is that if you make things here, because we have high labor and high health care and taxes and environmental laws, it costs you a lot more to make stuff here than it does to make things offshore. So as I mentioned, when I started giving this talk, someone might be sitting out there thinking, yeah, that's right, I'm going to go make my stuff in China because like this, I'm going to be able to make so much more money because the thing that used to cost me $1 to make is only going to cost me 50 cents to make in China. So they went off to China and made it. And today it's a little bit different than that because people have either already tried that or it's not as attractive in China anymore. So really what's happening is, and actually this is what I just said, they take whatever, a piece part, this clicker thing here, and they say, this is how much it costs me to make it here. I know that already. If I make it in China, it's going to be this much, and I have to pay this much to ship it from that country to America, and that's my next cost. And there's I could talk for a day about this, about why that's not actually the case. You have to think about shipping, inventory, insurance, quality, travel. This is where getting into risk of IT theft comes in. We've seen this like crazy about where someone decides to make this in China, and they make it, and because it's made in China and shipping's expensive, you have to make 1 million of them because that's the best way to get them to the market. So you do that. You make that commitment. You make it cheaply overseas. You make 1 million of these. It gets on a boat. The boat has to sit in the ocean for a month. And literally by the time you've made all that decision, this product is out of date and someone wants a new design. And now you're stuck with 1 million things that the guy that came up with a new idea made that you can't sell this anymore. And you're stuck at that point. So making things locally allows you to be much more agile because now I can make 50 of them. I can test the market. I can try to see if the market is accepting to it. And if it does, then I can make 200 of them. And if it's still good, then I can make 1 million of them. And I can distribute more readily, and I don't have to worry necessarily about the transportation costs. Plus, I still own all the IT for it. So as you mentioned, you might take some technology and trust somebody in a foreign country, and next thing you know, your exact products for sale in another country at half your cost too. So what we think is that taking something that you make here and changing the way you make it by adding automation, by adding technology, you're able to reduce the cost of the things you currently make here. And with some education, you realize that making things offshore costs more than you originally thought they might cost. And we think that puts us on a level playing field and even tips the scales over to try to make things locally here better in the end. Here's a couple examples. I'll go through these pretty quickly. We actually did a couple case studies where welding a part together. So when you weld stuff together, I'm trying to think of something that's welded, like the seat, the metal frames of the seats you guys are all sitting in. Those things need to be made. They get made out of metal and they get welded together. And when you would use American labor versus Chinese labor, you can see that it cost 84 cents a part versus 30 cents a part. This is a real case study that we did. However, when you automate that process, we can get down to 30 cents a part as well. So there's an initial investment that gets made, but the labor gets reduced, the product quality goes up, the productivity goes up, and the price goes down. The same thing with some machining studies where it's the same kind of thing. It costs more with labor, and then you start to automate it, and it gets cheaper. So it helps. One of the things that I see in manufacturing today is, as I mentioned before, I used to go into plants all the time and say, let's automate. And they say, no, I can't. I don't want to lay off my people. Today is a little bit different. When I go into plants today, I'll go in and they'll say, I'm dying because Ford just gave me this contract to make 1 million parts for their upcoming program, and I can't find skilled labor to actually do what I need to do anymore. I've got a whole other presentation about the baby boomers retiring and millennials coming up, where there's a 30 million person worker gap that we're right in the midst of right now, where more people are retiring than are coming into the workforce. The recession didn't help as well because that created early retirement for a huge sector of the manufacturing business. And we haven't been training skilled employees as well as we should have as well. So there's this huge gap right now where manufacturers are out there, even if they wanted to do it by hand, they can't find the people to do it by hand. So today I go in and they say, listen, I got to make 1 million parts, and can you help me automate to be able to do that in the most cost-effective way? So it's not so much about trying to replace people, it's trying to take my business where I currently did 500,000 parts, and I need to get to 1 million parts, and what's the best way for me to do that? And automating is the way. So it helps with the skilled labor. There's no healthcare required, obviously. When you do things with robots, you get consistent quality. It reduces the material cost. They can certainly work all day long. When you can use robots, the robots have cameras and stuff on them where you can do the inspections automatically. So this isn't the first time that this has happened in manufacturing. This has happened before. Farming is the first example. It's important to kind of take note. This is on the quiz later. Farming in the 1900s, 38% of our entire country were farmers. And a few years ago, 2% of our employment were farmers. And when you look at it, this is kind of the way people think of manufacturing today, is there was a lot of people in manufacturing and now there's less people in manufacturing. It's not as dramatic as this. But look what happened with farming. We have, just since 1961, our agricultural exports have increased 300%. Today, we're the largest exporter of food in the world. And it's because it changed. Guys with oxes and plows just couldn't sustain the population growth. It had to change. We needed automation. And there's actually no robots really in farming per se right now, but it's machinery, it's stuff that we use to be more efficient, and which meant less people. But the industry's healthy, and we make a lot of food. We make the most food out of anybody, and the productivity's gone up. So it's happened before. Same thing in the steel industry. The steel industry from the 80s until now decreased 70%, but our output went up 28%. And in 2011, there was a 75% capacity utilization rate. That's really, really good, a 75% capacity utilization rate. So the steel industry has kind of gone through this as well. And again, technology is the key. They use technology. Otherwise, and this has happened a bit in the steel industry, where steel manufacturing has gone offshore. It has gone to other countries. But we've been able to maintain a significant portion of that here in the States as well. This slide is really just to summarize some of the things. This means we're not the only ones looking at it. This came from the Boston Consulting Group, where this highlights kind of what I was talking about in the beginning, where labor cost is a share of product cost. So how much labor goes into actually making something. And then on the bottom here is how much logistics cost as a share of its price. And by analyzing a data like this, you can look at things that are likely to remain offshored that have high labor content and it doesn't cost very much to ship. So if there's a very high labor content that needs to happen and it doesn't cost a whole lot to ship, like apparel and footwear, then it's offshore and it's going to stay offshore. But when you look at things that are kind of in the middle here, that have a medium labor and start to get more expensive, these are a lot of the industries we're looking into. Plastics and rubber, electronics, computers, transportation goods, furniture, and things like that. So those are the types of things. So there's a lot of people actually looking at this right now, not just us. All right, so in general, in summary, again, take note, a lot of reason why people are looking to come back. They're looking at the rising labor costs in China. China's labor costs now exceed that of the labor costs in Mexico, where Mexico is now the cheapest labor country to do business in. There's increasing fuel costs to ship things to North America. It's very, very expensive to ship product to North America. And then, as I mentioned, there's kind of a national desire now to be more control of the manufacturing process and the quality of the products that are coming in, which is why it's called reshoring. That's a term that people use today. It's called reshoring. Okay? But there's room for growth. Look at some of these statistics. This is kind of interesting. When we look at total employment in manufacturing, and we look at how many robots we sell in manufacturing. This is not just our robots. This is all the robots. So in U.S. manufacturing, if you look at all the employees, there's one robot to every 86 employees. So that tells you how many employees we have in manufacturing, how many robots we have, and we do the ratio. In Japanese manufacturing, there's one robot to every 32 employees. Korea is a very similar number. So that means they're much more automated. They have less people, number one, but they're much more technological countries and have a lot more people. At our factory, at FANUC, where I work, there's actually 10 robots to every person. And it's totally flipped over. Like I said, we use 2,700 robots in our own factories, where we have 10 robots to every person in manufacturing. So, again, FANUC's a very, very automated company. But these are just some of the numbers to show that even to get into the Japanese area, Germany also has a very good number in terms of robots to manufacturing people. So those countries, we're pretty good, but there's still a lot of room for growth there. So in summary, like I said, we're trying to save U.S. manufacturing. I work for FANUC in America. We're trying to keep manufacturing in America. By doing that, we think it's going to have a positive impact on the U.S. economy. It's one of the main drivers for growth in our economy, and also have a positive impact on the environment. We're trying to reduce energy costs like crazy. So that's really what we're trying to do. I think that's it. Any questions for me? Was that the best guest presentation you guys have had all year? Thank you very much.